And I should have said earlier, my name's Nick Tate. I'm based at the University of Queensland with my co-chair, Viviane Paz. We're chairing a number of the plenary sessions of the conference. So it's my job to chair this morning's plenary session, which is actually a great joy rather than any problem. And indeed, we are equipped with the latest in technology for timekeeping, as befits, of course, this almost parliamentary style room that we have here. But so confident am I that you're going to enjoy our first speaker this morning that he wouldn't in any way go over time. You'll see that we have actually taped up the gong to this morning. So that's a mark of confidence that the chairing will not be a difficult one this morning. So I do need to give you, I will give you a few further housekeeping directions when we finish today's session and how we're going to split up into sessions after today's plenary session. But in the meantime, it's really a great pleasure and privilege to be able to introduce to you our first plenary speaker this morning, Dr. Cliff Jacobs. Dr. Jacobs has been working with the National Science Foundation, or NSF, in the United States for 27 years. And for 25 years of that time, he's provided oversight to the National Centre for Atmospheric Research, known as NCAR, and its managing organisation, the University Corporation for Atmospheric Research. NCAR is the largest assistance award made by the NSF for roughly $100 million a year. And of course, I'm sure we're all thinking of that in the Australian context as well, even with the high Australian dollar. Just at the moment. So Dr. Jacobs recently has assisted the NSF with various procurement activities. He's providing support services to the US Antarctic program and with many contracts running of several $1 billion over 13 years or so. Whilst on detail to the OPP, he's helped guide the upgrade of the National Ice Core Laboratory and has provided a framework for the competition for the management of NICL. So he's had enormous experience in this area. Within the Geosciences Directorate Office, Dr. Jacobs assists with the oversight, planning and execution of several complex agency activities, including the operation and management of major facilities and the EarthCube endeavour. He co-chairs an internal directorate working group on geoinformatics and data and serves as a member of the Geofacilities Working Group. Before coming to the National Science Foundation, Dr. Jacobs was Executive Vice President of Senior Research Scientist at the Centre for the Environment and Man in Hartford, Connecticut. And Dr. Jacobs and colleagues at the Travellers Research Centre and later the Centre for Environment and Man conducted pioneering studies in air-sea interactions and regional modelling. In addition, his basic research interests include data analysis of large environmental databases and development of computer graphics software for the analysis of observed and model data. Domestic and foreign governments, as well as private industry, have sponsored Dr. Jacobs' research. It gives me a great deal of pleasure to invite Dr. Cliff Jacobs to come up here and talk to us today about EarthCube, a transformational concept for geosciences. Please welcome him.
Good morning, everyone. Thank you for the invitation. Thank you for the sponsors to make this activity possible. I certainly appreciate the opportunity to tell you about something we've been up to in the United States called EarthCube, and it is an experiment. It is still pretty early on in the stages of development, and we're learning every day from the information we gain from the community. But let me advance to the outline. First of all, I want to acknowledge the folks that have been involved in this. There's been a team at the National Science Foundation that has been working to make EarthCube possible. And there's some letters after all of those names, and they represent the internal organizations within the National Science Foundation. And those organizations are the Office of Cyber Infrastructure, the Geoscience Directorate, and the Computer Science Directorate as well. There have been two leaders in the National Science Foundation that have certainly encouraged this and provided some guidance over time, and that's Tim Killeen and Alan Blatecki. Tim has left the National Science Foundation, but Alan is still there, but they deserve credit for helping this move along. The outline of this talk is I wanted to provide a context for the EarthCube activity, and then tell you what our vision is for EarthCube, and a number of activities we've actually carried out to date, and it's been a discovery process about the process and how the community reacts, and appreciation of the importance of introducing social science into the activity early on, and certainly the exceeded expectations that we've had from the community in terms of their contributions. And then we want to talk about the balances and challenges that we see early on and some of the things that we can try to deal with in the future. And a bit of reflection about what we've learned from this process, and it is what I am terming the rapid prototyping of the process itself. The computer scientists understand that term, rapid prototyping, where you try systems and they don't work, you retry them. But we are applying it now to the actual process, where you change the process or where you're trying to affect some means. And finally, a little bit about the next steps that we plan to go through. So what's the science context and the cyber infrastructure context for EarthCube? Well, I'm going to refer to one report, but it is not unique in the terms of the kinds of reports that exist not only in Australia, but in the US and in Europe, for example. But one of the things this report said, and we call it the GeoVision report, and it was written in 2009 by our advisory committee for the Geosciences Directorate. They're talking about fostering a sustainable future in a very complex planet. And so when they talk about the purpose of it, they recognize that the purpose of this report was really to get us to think holistically about the planet and bring in experiences from all of the aspects of science and engineering so that we can really address the concept holistically. The report went on to, in a very bold statement, to say something about a call to action. And when I read that call to action, over the next decade, the geosciences community commits to developing a framework to understand and predict responses of the Earth as a system, from the space-atmosphere boundary to the core, including the influences of human ecosystems. That is a pretty profound statement, and it gives us a time frame of a decade. But I also realize that we do not have the cyber infrastructure and supporting research infrastructure in place to actually accomplish that. So that was one of the contexts we looked at. And the other context, of course, you know, that is that geosciences, as well as several other sciences, can easily say they're increasingly born digital. So this is some examples of what we're up to in the US, but there's other examples in Australia and Europe and New Zealand as well. So we have Antarctic research vessel we just launched. We have a major initiative in Ocean Obs, several $100 million to observe the ocean holistically. We have EarthScope, which is an activity that's trying to understand the physical aspects of the Earth, solid Earth. We have activities in the water, the critical zone activities. We certainly have billions being spent on satellites, not only in the US, but in Europe and others. And of course, we have a great deal of simulation. All of that is creating a very challenging situation for us to deal with. When we look at the idea of where the geoscience data exists, it exists every place in this pyramid. And we have certain aspects of the things, of the data. Certainly you have the personally held data archives by folks that are in their desks, and we joke sometimes that one of the things we have to consider in EarthCube is that the geologists might have their database as a box of rocks under their desk, as well as some very sophisticated databases that are available in the community and are taken, for example, like the NCAR maintains a curated data set of ocean observation, surface temperature observations dating well back into the 1800s. But that took a lot of time. It's available publicly. It takes a lot of effort to curate those databases. So we have this spectrum of data, and geosciences exists in various aspects of that spectrum. And we have to worry about how we actually ensure that the data, it has a path to move from the individual investigator all the way up to the patriarchal data. Let me talk a little bit about the context for cyber infrastructure. And a quote I put here was a report that was produced back almost a decade ago that was actually significant in the U.S. in terms of defining the idea of cyber infrastructure in a very broad context. We call that oftentimes the Atkins report because it was authored by Dan Atkins from the University of Michigan. But he talks about the idea of building a new type of science and engineering knowledge environment and organizations, and that we want to pursue research in new ways with increased efficacy. So this is really where we're at. Can we build a new kind of knowledge environment and a new types of organizations that actually will deal with cyber infrastructure? When we look at what's going on, not only in the geosciences, but a lot of places, we understand that we are in this data deluge, that modern science is all about data and computation-intensive activities. We know that we have a lot of collaborations across the individual groups, across large organizations, and we certainly have a sea of data of activities. And the data keeps coming and coming, and it's going to get worse in the future. In the geosciences, we have data at rest and we have data in motion. And so we have to deal with those. And we have the idea of data needing to be analyzed very quickly. And over time, they will have to deal with those. And the databases will become larger and larger. When you think about the cyber infrastructure, you need to think about it in terms of an ecosystem. All of the elements that are indicated in this diagram are actually what it comes into play when we use an environmental, an ecosystem like this. They also want to take the opportunity to say that EarthCube is actually an aspect of a large activity in the National Science Foundation called Cyber Infrastructure for the 21st Century. We're receiving funding from Congress for that activity. And that geosciences, as I said, our contribution to cyber infrastructure for the 21st century is EarthCube. And as you saw early on, we have sponsorship from that group that is supporting that. We need to create an environment, an ecosystem that is maintainable, sustainable, and extendable over time. But this is the context that we have to deal with in. So what is our vision for EarthCube? We really want to think about transforming the conduct of science, and we'll talk a little bit in the next few slides about why we need to do that. So we start with a very interesting idea. When we started EarthCube, we said, all we want to specify is here's an outcome, and we need to define the process. Nothing in between. Let it all be defined by the community. So what we wanted to do is our goal was to transform the conduct of research in geosciences, supporting the development of a community-guided cyber infrastructure that integrates data and information across the geosciences. And what will be the outcomes? The outcomes are, here's what we want to achieve in a decade or so. We want to transform the practice within geosciences over that next decade. And probably a decade is too short, but it's going to take a time. What we want to do is provide unprecedented new capabilities to researchers and educators. New capabilities, not things that they have now, but we want to create new things. And we really want to vastly improve their productivity. The productivity of scientists is not as high as it should be. One of the researchers in the U.S. says that if you take a typical NSF grant, 80% of the resources are spent finding the data and conditioning the data, getting it ready to do the research, and 20% is spent doing the research. We need to reverse that. You shouldn't have that much trouble finding all the data and getting it in a type of format you actually need it to actually conduct your research. But the state of the fact is that we don't actually have that in place at this point, and that means that you're unproductive in the research dollars you're spending. We certainly want to, as a goal, to accelerate the research on the Earth system and provide this knowledge environment framework for all of geosciences. And I wanted to go on a little bit more and say something what we meant by this knowledge environment. This is based on some ideas that have been around for a decade or so, but we're defining these quadrants here as the real way that research is actually done. We all use these quadrants in different ways. So we have making knowledge visible. Can you go on the internet and find a database or particular people that might be doing things? Yes, we certainly can do that. Some of the bullets here are actually haven't been developed yet. Is there a yellow pages that you could go to find out who would know something about particular rock formations in an area? That doesn't exist yet. Do you know who the most competent people are in certain areas? That doesn't really quite exist yet, although you know it from a social context when you read journals or you come to particular events like this. Then the idea of building knowledge intensity, that's training face-to-face, research conferences like this where we're personally understanding what other people are doing and making connections. We want to know that where there's competency centers, I funded for a lot of years places like NCAR, which has a great deal of competence in a variety of activities, but it was a very expensive competence center. And there's other areas about managing knowledges and networking activities. The one that we oftentimes talk about is in the lower left-hand corner. That is the knowledge infrastructure, the cyber infrastructure activities, which are building common frameworks for that. But the other part in the developing knowledge cultures is also an important aspect. And so that we have to recognize there's value in culture systems in all the ways we do research. And there is a reward system associated with those as well. We have to recognize that. And we have to have a shared mindset of how to transform that. Although all of these things actually are in place in the way they do research, what we haven't done is strategically integrate these in a synergistic way so you have a seamless environment in which all of those can happen because we're using that paradigm already. So when we look at some of the things we've done in the National Science Foundation and some of our sister agencies in the U.S., we realize those dots on the left-hand side represent programs. So Unidata, NCAR, there's several other ones, the Ocean Observation System. There are all these major activities. But what we've done is they've created infrastructure that supports their particular communities very well. Unidata does it for weather. NCAR does it for climate modeling and weather modeling. There's an activity which does it for critical zone and water considerations, hydrology, and other activities like that. What we built is very good and effective stovepipes, but they don't actually talk to each other because if you want to look at the Earth system, it doesn't work quite that way. So our idea is that we need to take these and some of those smaller dots or other activities that are going on within the geosciences and be able to define a process how they can work together so that you do have the outcome that you want. Now, this is sometimes referred to the bubble diagram. And if the Earth system had a sense of humor, it would laugh. This is the way we've decided to divide up the Earth system. The Earth system actually operates as one holistic, integrated system. But this is the way we fund it. And these bubbles represent programs in the National Science Foundation that researchers can send proposals to, or major activities that support activities throughout the geosciences community. So we have a combination of cyber infrastructure activities, we have ideas of Earth scope and plate tectonics, and we have physical meteorology, we have biological oceanography. These are all separate programs, all creating particular infrastructures for their community. And this is the target community we need to get to. This is where the real researchers are doing research. And we're going to talk a little bit in the next few slides about how do we integrate these folks into the EarthCube activity, because it's our real target audience. So our strategic idea is that you're going to go a spiral development. A little bit at a time, you put pieces in place, and it'll be at least a decade, and maybe the decade is a little bit optimistic. But there is an underlying premise in that, because there's a lot of good things that exist out there now that are serving communities very, very well. The premise is that if the last 10 years is an indicator of the next 10 years, the technology refreshment will be very significant. In other words, most of the things we're using now will not be the things we're using 10 years from now. And when you do the technology refreshment on whatever your area is, that if you have a framework that you could put it into, you are likely to have an outcome that's a little bit more synergistic than the current free form, where a new piece of technology comes along for a particular group and they pick that. They could have picked something else, and so another group picks another piece of technology, and you don't actually have any convergence in that. So we're trying to get this idea across that in time, if you, community, decide where the framework ought to be, you will have a way to get a convergence over the next decade. But I'm going to pick one of the set of challenges we have, and I take this from a recent European group. This is only dealing with the data, but it does highlight some of the things that we have to deal with. So the collections of data is, do you know when you're collecting data, from a cultural point of view, that they're collecting sufficient metadata to actually be able to use this? Do you trust the data over time? How do you find the usability of that data? Is it in a form that is usable? Is it interoperable? Then the diversity of data forms that might come in the Earth system, where it might be rocks to biology and everything in between. How do you trust the data? Security, how can you maintain that? The education and training process that you'll need for not only the researchers, but access to the data by the general public. Then the idea of publishing the actual data underlying articles is another example of that. And then the commercial exploitation, that is, a lot of what's happened in the geosciences and other areas have actually been developments in the commercial sector that have helped us. For example, Google Map. Many of us use Google Map. Geosciences didn't invent Google Map. They invented it for their reasons. We're exploiting it. There are a number of other things that will happen over the next decade, so we need to make sure that we can exploit the commercial developments. Then the other ideas of social paradigms, like crowdsourcing of information, is important when we consider data. And the preservation and sustainability are other issues. So just in a small context of dealing with data, we have to consider all of these things in the long-term activities, and how we're going to address them is going to be significant. So what have we been doing to date? And this activity has only been going on for a little more than a year, okay? So the first thing is we engaged social sciences pretty early in the process, and I'll talk a little bit about that. And then we engaged the people that we thought would be engaged right away, but we knew that they weren't the right people. Before we actually started EarthCube, when we issued something called a Dear Colleague letter, I'll talk about that in a minute, we knew the first people to be at our door would be the cyber folks. They said, we can build whatever you need. Just tell us what it is, we need the project, and we absolutely need them involved in that. But they don't necessarily represent how the research is being done. They are connected. The folks that came to the table were connected to the geosciences community, but they were not a sufficient number of, sufficient scope in terms of the assets we had. So we had some early engagement. We knew it wasn't sufficient. We knew we wouldn't be able to address the researchers who existed in that previous bubble diagram that I talked about. But so let's talk about some of the things. So the social scientists say, if you are going to create an institution and system requirements, you have to be able to demonstrate it creates value, it mitigates harm, and it is sustainable and agile. So in terms of create value, it has to be able to not divide the pie up, but actually create the pie in an effective way that expands it in a transformational way. mitigating harm, you have to make sure that anybody who's engaged in EarthCube is not going to feel that it's going to come back and bite them, and those could be some kind of catastrophic failure, like they submitted their precious data to some website that's created or a database that's created and it's lost. And it's certainly a fair, effective, and robust rules of engagement. That really implies something we'll talk about in a minute, and that is governance. How is this activity going to be governed? So in the early stakeholder alignment activity, we engaged an experienced investigator, Dr Clifford Jacobs, and from the University of Illinois, Urbana. And what he had a lot of experience in, he was already an awardee of NSF for doing other kinds of social science research. He had experience with industry and other kinds of activities, and was very fascinated. His research objective was, how do you actually demonstrate stakeholder alignment? And we'll talk about that in the next slide or two. So he brought that experience, and we did some surveys early on. We did a survey of the folks that were the early adopters. Those are the cyber folks. Tell us what you need, we can build it, and we already have terrific case studies developed that might not necessarily reflect actually how the research is being done, but they might reflect challenges to the cyber infrastructure to see whether it can function under various scenarios. And then we had another type of survey where we actually started talking to the people in the bubble diagram, all of those other researchers out there. So we had these two kinds of results, and we'll talk about them in a minute. And this idea that he's come up with, Joel has come up with, was this Z-flower representation. So I want to say something about that. The Z-flower representation, essentially you ask questions and you have a range of scales from 1 to 17 between negative and positive, and you're able to take the mean of that and plot the individual ideas around those. And so you see those uniform, everything would be green. Bimodal, you basically plot these individual responses, and then you have a very mixed result there. So what he's done is try to figure out, how do you know if you have stakeholder alignment? Because stakeholder alignment in something like EarthCube or whatever you're building, these major infrastructure, is really an important thing, and it is a requirement. How do you really know if you're being effective? And part of it was a question asked early on in EarthCube, and that question was, how do you know if EarthCube is going to be effective? So doing an early survey, and maybe 1-2 years from now, might show you differences. So I'm going to pick one of the questions that we asked the community: the importance and ease of access of data within your field. So what you see here is that we have ease of access is really, really important to both the early adopters of EarthCube and the ones that had low involvement. They both agree, in the left-hand set of panels, they both agree it's really, really important. When you ask them how easy it is to access data, then you start getting very mixed results about how easy it is to access data. So you can see that there is some indication of where the efforts have to be put and what kinds of information you can gather and display with this particular approach. The other thing we did was set up a social network. Outside of the National Science Foundation, we had a facilitator early on in this activity, and they suggested we set this up. We have about 1,200 people, there's probably more now, that are on that thing. It represents the intellectual commons that people could communicate about EarthCube and their ideas. We had an early request for white papers about how would you what would you do with EarthCube to really realize this vision that I had presented a few slides ago? We had 113 white papers. We had a number of people that responded to surveys and early on. And then we put out an idea that said, send us some emails of expressions of interest of how you could contribute to EarthCube. And this was very, very interesting, and it was part of an example of the rapid prototyping process. We thought that as a result of the white paper and the expressions of interest, people would get the idea and be able to move forward. And we had to regroup. They didn't get the idea at all. They could not think beyond their parochial ideas or the way that they had done things to begin with. For example, in the expressions of interest, we had 7 submissions of ideas about ontologies and semantics by different groups in the U.S. And we're saying, wait a minute, ontology and semantics have 7 different groups, none of talking to each other. How could you possibly have a dictionary for 7 different dictionaries for geosciences? So we did something which NSF doesn't usually do. We sent these folks an email and said, look, you're all talking about the same idea. Would you pick one leader and submit a proposal to us for a workshop? And surprisingly, and we did this for a number of people, they did actually said, yes, we would do that. And another thing that we didn't realize at the beginning, was that the geosciences community, despite the fact that they're all talking about looking at the Earth in different ways, is surprisingly isolated. So the example of the people didn't know really, from oceanography to biological sciences to geological science, what they actually were doing. They kind of vaguely knew, but this is a role that the NSF was trying to play as a facilitator of a dialogue. So as a result of those 7 expressions of interest, we funded several activities, and I'll talk about those in a minute. And we really got a lot of hours on pro bono hours, because we didn't pay anybody to submit these ideas to us. They just did, and they presented a number of significant white papers. They're all on the website. And so we really got an unprecedented sense of the pulse of the community. And one of the things we realized is that besides they don't really talk to each other very much, is that they really needed to have somebody help them get to where they needed to be. So the timeline that we started with our first Dear Colleague letter, and the Dear Colleague letter is an administrative way that the National Science Foundation says to the community and posts on our website, hey, here's what we're thinking about. And maybe it'll ask for you to send ideas or comments on it, not actually proposals. So Dear Colleague letter is when we declared EarthCube back in June of 2011. We had a WebEx, try to continue to interact with the community and telling them how we were going to proceed, what our vision was, try to get the shared vision. Then we had the first charrette, a brand new word for some of us. And the charrette is a common mechanism used by architects, where you have a lot of different ideas, you come together and you come to some agreement. Technically, I think the French word is derived from the cart that was taking the folks to the guillotine, but we didn't want to talk about that too much. So the first charrette, we asked the community, a broad community, about 200 people came, and they said, what are your requirements? They listed 99 requirements. We were able to gel them down. So at least we wanted to know what they thought the requirements were. Then we did something, pardon my the language here, the eager phase, and that is, these are types of awards that NSF could make, workshops and eagers. What we wanted to do was employ all the mechanisms we could possibly employ within NSF to get the money out the door very rapidly. So eager awards do not require external reviews. Workshops didn't require external reviews. So we could turn around money within probably a month or so. By the time they submitted the proposal, we could make an award within maybe 6 weeks. The idea was to build the momentum and get the money out there. We had a second charrette after those awards were made. We'll talk about that second charrette in a minute. But that was also one in which we asked for convergence, and we'll see in the next slide or two what that is. So we started asking these folks to develop roadmaps. We have a first PI workshop where they came together. We also did some updates to the roadmaps, and we also have a European workshop that talked about EarthCube. And then we had a second PI workshop recently, back in July, I think. No, it was in September. So what we actually funded on this rapid development is, so we funded several groups doing data and discovery. That was one of the things that came out of the expressions of interest. There was a whole bunch of people saying we got a way to discover data and do data mining. Again, we called them up and basically said, would you submit one proposal? They did. Semantics and ontologies. Several people wanted to do things about workflows. Would you all get together, do workflows? Then there was some governance, various ideas on governance. So those blue groups we funded through workshop type of activities. And then there was a number of building blocks ideas where people said, oh, we've got a perfect model. We're ready to expand that model and make it more functional for EarthCube. There were things like data brokering. That's a technology that can go across databases. It's the absolute thing that EarthCube needs. So we funded a number of these folks to do these things, as you see in these what we call the concept awards and the ones that are in pink there. But what we told them to do was don't do anything. The concept awards or the other ones, don't do anything except develop a roadmap. If you have any money left over, you can do some demonstrations. We want to know what each group has in mind for a roadmap. And our idea was that all the roadmaps, which is going to be all developed by the same common framework, everybody speak to this framework. And then by preconditioning the community through this process, we actually were hoping to come to the second charrette with everybody started thinking in the same framework and would be able to have some convergence. So when we asked them to do the roadmap, say, what's the purpose of your roadmap? How are you going to communicate that? What are the challenges you think you have to overcome? Where are you going to get the requirements? How do you define them? What's the current status of the technology or the knowledge in the community? What do you think the possible range of solutions are? We're not looking for a particular solution. We're looking for much more about the process you go through. And then we wanted to know how long the timeline is going to be, how would you manage it, how do you mitigate risk. So everybody wrote to those roadmaps. They're all on that EarthCube website. Some of them were 200 pages long, really a thoughtful set of activities. And believe me, we didn't fund these things more than a couple $100,000 or $100,000 to develop these roadmaps. So that's the part that exceeded our expectation, how the community came together. Part of the way we picked these awards was these are groups that have never talked to each other but have a significant voice in their communities. We wanted them to talk to each other, and we asked them to come together and do the roadmap. It really did help it. And it is all part of an activity we think you need to precondition the community maybe over a couple of years before you actually move forward with the major award. So maintaining the balance and broadening the dialogue. The important activity is that the first group that were involved, these early adopters, were dealing with a number of things you already saw in the previous diagram. Everything from workflows to physical samples, and they were the ones that were in part of that. What we really haven't dealt with as well is the governance. We think that's important. And one of the things we're saying to the EarthCube community is governance is important. You have to figure out how this is going to be governed. The National Science Foundation is not going to be involved. We'll be a facilitator, but the community has to decide what the right things are. And we have been very cautious about specifying the part of EarthCube. For example, one of the things that seems obvious is you need to develop standards. Well, we're not going to say that. Does the community come to a recognition that standards are absolutely important and the governance wants to make sure that that's a high priority area? That's the approach we're taking in there. But the education and workforce and the collaborative environment. And there's a whole bunch of other institutional things that we have to consider that are listed in that blue box as well. And all of those we're starting to make some progress on, but some are outside of our realm at all, about the idea of promotion and tenure system within the U.S. Academic system. How do you overcome that if there is no incentive for them to participate in EarthCube? But it is part of the environment that research is done in. So this early engagement, engaging the social scientists provided us valuable insight. It's also a way that we think we can assess how effective EarthCube is in several years by continuing to look at the survey. We wanted to encourage those folks in that bubble diagram to get involved, and so we're funding quite a number of workshops, all designed to have a same framework. Tell us about what would be important for your community for EarthCube to contribute to your community. Where are your challenges? Where are your barriers that you would like to overcome? What things would you like to do in the longer term in terms of your science? And then the last thing is we must consider several things like the technical and social motivations for these large number of people that are involved in that bubble diagram, the actual researchers. So the technical motivations we recognize are getting the science done. A researcher says, that's what I'm really interested about. I want to get my science done, and I want to get it done effectively, efficiently. I want to have more capability and more productivity than I have now. We need to identify these barriers, and we hope the workshop will identify that. For example, we don't know if this is going to come out, but they might say a number of people have data sets, but they have no place to store them. Is there some mechanism that we could set up that would allow them to store their data sets rather than on their home computer or wherever they keep their data sets now? And the access to actual resources, both data and cyber infrastructure, they might not have it. Some of the groups that we know are collecting data in a major project, collecting data in Excel spreadsheets, and they've developed macros for that. Is that the best way to do it? I mean, really, they don't really have the access to the cyber infrastructure resources that they might have otherwise. And certainly understanding the complexities, the multifaceted, multivariate ways that people actually use data and conduct research is important. Some of the social motivations are, basically, will geosciences really share the data? And if you build it, would they actually come? Other things like, will geosciences and computer sciences actually collaborate? What's their incentive to cooperate? I think we have to recognize that, and it was part of the early slides about building the value system. And also the interdisciplinary work of sufficient scale to really, really tackle the research. And do we have a collective vision of what success would be? So those are some of the things. And when you look on the right-hand side, you see some of the barriers that have already been identified in the early surveys. So researchers are saying things like, I don't really have enough time to do quality assurance and quality control of my data. There's just nothing there. There really isn't any repository for me to put my data in, or if there is, I don't know where it is. Inadequate standards or standardization of formats. I can prepare my data any way I need to just to get my work done. And I certainly don't want to share my data until I've actually published something, so that's part of the value system. And sometimes the data sets are too large or too complex to actually share. And there's absolutely no incentive credits for actually sharing data. So these are some of the feedbacks we're getting from the community. So other things that we have to consider to really approach EarthCube with what we say is wide open eyes on this is the ideas of the various fields which are represented by their own subcultures in that bubble diagram, as well as the variation in age of research, the old researchers and the young researchers. One of the things we have said to some of the younger researchers is when you decided to become a graduate student or you're now a postdoc, you were basically handed a system that you had nothing to do with creating. So what we want to know is what kind of system would you like to, an environment would you like to actually do your research in? And so we're engaging the early career scientists early on in our activity to get that input. Rather than you being given a system, we want you to create the system that you think will be the best to advance your research. There's home institutions for many of the researchers. Each one has their own variation, culture that we have to recognize. There's a whole bunch of other things that are listed on there. And the last one, of course, is the fact that we are trying to stay on the back of the galloping pony of technology. which is just speeding along, and everything gets refreshed in a year or two, and we're trying to keep on top of that. So these are other things that we must consider. So a little bit of reflection about where we're at now and what we've learned. I mentioned previously the rapid prototyping. When we thought we understood what the community was going to say and how they're going to respond, and then they responded, and it wasn't what we expected at all. And so you get a lot of insight by looking at those and going through this process. And so we kept changing what we wanted done when we got feedback from the community. Well, that didn't work. Let's try something else. Oftentimes, agencies will, have a particular process, and you go through and you just keep turning the crank, but it isn't necessarily going to be the outcome you want, because the process has shaped the outcomes in a ways that perhaps is not the most effective for the ultimate goal you would like. So this is a little presumptuous on my part. NSF's 7 modes of success. Well, we don't really know if we're successful, but bear with me on this, the presumption. We were very proactive. Again, we took our role as a facilitator, not a funder, a facilitator for the community, and we took that very seriously. We began with an end goal in mind, and we saw that before. We want to transform the conduct of research. We don't know exactly how to do that. We want you, community, to tell us how you're going to do that. We prioritized tasks. We knew early on that we needed to have governance as one of the first awards we actually make. It is unclear at this point when we put out a solicitation, I'll talk about that in a minute or two, for governance models. We spent a lot of time and effort trying to look at possible models for governance, and there are a number of out there, and engaging the community in the thought of governance. But that is one of our priorities. If we cannot establish a governance, the community cannot agree on a governance, then we're going to have to do the rapid prototyping again and figure out, well, how do we move forward without a governance mechanism? We certainly emphasize a non-competitive, broadly inclusive activity. So when we first started EarthCube and there was money available, one of the first instincts would be, okay, we'll have a solicitation. Send us your best ideas for how to build EarthCube. And we would certainly get some interesting ideas. We saw that in the white papers, but none of them really could conceptually understand what EarthCube was about. And perhaps it was a little naive on our part to think that they would think that way. So that was part of the rapid prototyping was we really need to have this dialogue for several years with the community before we come to this collective vision about that. But we wanted to make sure it wasn't a competitive process. We wanted to be as broadly inclusive as possible. We listened to the community. We shared our vision in a number of ways. We participated in that website. We had WebExes. We kept talking to the community about what we would like to accomplish in the end. And we facilitated a synergy across the community that had never existed before through these relatively small amount of money, but a lot of effort put in by a number of people. And we internally engaged the program officers at NSF and sister agencies in the dialogue about EarthCube. And we thought that was important. When we think about how those activities within the bubble diagram, there are program officers that oversee those programs, and they are well connected to the university community, and they know who the leaders are in that community. And we've engaged them in saying, we need your community form a workshop so we can understand that. So we use the internal resources to reach out to the community to get them involved. So maybe these are the 7 modes of success. We'll see. But I think more important is the 7 modes of failure. So the 7 modes of failure are clearly unrealistic or misaligned expectations among the people involved in EarthCube. We need to make sure their expectations are really aligned with what we're going to accomplish. The idea of build it and they will come, the cyber folks say, just give us the money, we'll build it, we'll figure out, what people's needs are afterwards, or we think we know what their needs are, and they might not really understand that at all. And certainly we invest in the geosciences, for example. We invest over $100 million a year supporting cyber infrastructure for the geosciences. So there's a lot of existing infrastructure out there, and we need to value it because they serve the communities very, very well, whether it be the weather community, the ocean community, or the solid earth community. They are serving an important purpose. The other modes of failure is if we only incremental. We're not transformational in the way we think about this. We really want the community to think transformational, not just an incremental way of moving it forward. And not engaging the 14,000 plus folks now. That number 14,000, it turns out that we actually provide support to 14,000 people in geosciences. The cyber folks are supported, the number is even larger than that. But if you don't engage the significant number of people that are actually supported by the geosciences, then EarthCube could not be a success. And not really anticipating the needs of the next generation geosciences as well as the cyber infrastructure scientists. There's the most creative ideas. They're going to come from the young folks. And if we don't anticipate how they want to do their research in the future, then EarthCube would not be successful. And then, of course, there is that famous thing that our former Secretary of Defense talked about, the unknown unknowns. And we don't know what that is. A piece of technology could come along or some kind of transformation that we hadn't anticipated, and we invested too much in a certain particular way, and we didn't actually anticipate that kind of development. So here's some of the questions we think about all the time. So what are the best ways to capture what we've created now? We don't really know the full answer to that. What are the portfolio of activities we need to engage the scientific community in developing EarthCube? We are trying the workshops. We had early career workshops. We're trying disciplinary workshops. That might not be enough. How else do we want to do that? What are the effective mechanisms of engaging our sister organizations within the United States, our international partners, and also industry in the idea of EarthCube? And industry has been involved early on, and we're very thankful for that. And what are the effective ways that NSF can again be a facilitator? This is a new role. It's always been within our capability of that, and all governments have the role of facilitating the best intellectual resources of their communities to accomplish an end goal. And we need to learn how to be effective facilitators. We're still learning that, and part of that was that rapid prototyping that we've been going through. And then, of course, the last one is, what does it really mean to change community culture? And we don't actually know that, but we are trying to address that from the social science point of view, engaging them early on. That's the next steps. We want to build a set of solicitations that are broadly inclusive, that have a certain number of lines. So we expect an EarthCube solicitation to be issued, which will have, we've taken this approach where we're going to have one solicitation and we're going to have a series of amendments as we build the activity. Rather than have separate solicitations for this and that and the other thing, we wanted to have a consistent flow of ideas for EarthCube under these amendments. This is what we're going to do now. This is what we're going to do in the future. So we'll build it under one solicitation. We know that establishing governance is important, and it could be, speculate, that we'll put out the solicitation and ask for governance, and the community that's been coming together and talking about them could find this as an opportunity and completely fragment and have 10 different models for governance, rather than, what we'll have to do is we'll have to think about that. Do we really need to work more on how the community is going to govern themselves? We're engaging these community workshops. We'll fund at least a dozen of those, maybe more. We're going to put out ideas about architecture. What should the architecture of the EarthCube look like, and let the community decide that. We want to leverage a number of existing efforts that are going on both nationally and internationally, and we want to take advantage of all of the best thinking. As you saw in some of my diagrams or slides, that we really have tapped into what the Europeans are thinking, what other people are thinking, what industry is thinking. We are interested in the best ideas for EarthCube. We don't really care where they come from. And further engagement of our international partners, our federal agency folks, is really, really important, because when you look at the way U.S. researchers get their data, only about half comes from the National Science Foundation. more than half, I think, come from other agencies collected by NASA or NOAA or the European Space Agencies, other agencies. So we need to engage them in the dialogue because the data is coming for the research activities from a variety of sources, and it's important to have them all at the table talking to us. So that is my concluding remarks, and I will take some questions, and I hope you've enjoyed that. I certainly enjoyed sharing my ideas with you, and our EarthCube team thank you for the opportunity to present them. Yeah. We have one question.
I'm interested in the fact that the EarthCube will be not only to researchers but to governments, to commerce, to a broad community. You imagine that the governments that will work for the science community will be inclusive of governments that's been for the other communities, or would you imagine some shared environment?
Yeah. This is an interesting question because we're saying, what is the role of governance? We're asking that question. Are they the ones that are going to decide X, Y, and Z will be done in terms of project development, or will they be facilitators in terms of collaborative activities that are being funded by other areas? This is going to be the interesting part, and the way we're writing the solicitation is there will be certain, what we'll say, core values that governance must have, but what you actually do, we're waiting for them to define. Now, we've funded one group who's been working for more than a year developing this dialogue, and they've been very, very careful, this group, in not picking a particular model or particular way. They say, here are all the possibilities that exist. We're looking at things that are successful and other things that could be successful. We do not want to make ourselves an anointed body deciding what it's going to be. We need to have that as an open dialogue. And so we've also funded them again to reach out to the community for another 6 months, trying to have that dialogue at conferences like this around the world to talk about EarthCube and gather ideas about governance. So I don't know, a year from now, I might be able to answer that question and what we decide. And it is a little scary in terms of this is an important element because NSF does not want to run it. This has to be decided by, you guys all are frustrated, you want to come together, you want to do things, so here's your opportunity. This particular approach has been very unnerving to the community. They are used to us saying, here is a pot of money, here is some idea, send us your best ideas about why, whatever it might be, and they come back with ideas. But now we're turning the tables around on them and saying, you tell us how you want to run it, what are the important things to build this. All we can tell you is here's the outcome we want 10 years from now.
Andrew Trelaw from the Australian National Data Service, building on that question from Ross. I'm up the back. Aye.
Oh, I'm sorry.
I'll step out of the shadows.
I couldn't. You were in the shadows. I heard a voice.
So that was a fascinating talk about how to bring a community along, particularly like the way you involve the social science researchers in the early formation stages. I wonder if you could reflect on how well the approach you've described would generalise to other disciplines. Is this something that's only going to work with the geoscience folks, or could you imagine an EarthCube-like initiative for some of the other disciplines, both in the sciences but also in the social sciences or humanities?
Well, of course, I'll throw the caveat in. We don't even know if it's going to work for geosciences, but our colleagues within the National Science Foundation, in physics, for example, astronomy, in biology, are actually looking at our model as an interesting approach. And they're trying to put together ideas about charrettes and bringing communities together. So some of the things that we've done, innovative, have been adopted by a few federal agencies are watching with I guess, a great deal of interest about whether this is going to be possible for them to participate in this EarthCube thing. When you think about the National Science Foundation relative to the other agencies, we are a $7.5 billion agency. We're small compared to NASA or NOAA. We do have one benefit of the $7.5 million is that we give it all away every year. And the other agencies do actually do research, and I oftentimes joke the National Science Foundation does absolutely nothing except give away money. So they actually are conducted in real research, and they've built a lot of infrastructure and collect a lot of data. So they have found, we hope, that if there is a particular voice in the community that evolves over the next several years, this would be a great way to interact with the community at large. Some of the programs that we've had developed over the years, for example, Unidata, which I sponsored for a number of years, one of the outcomes for that was that it was basically weather data, and NOAA was a key provider of that weather data. But NOAA did not have the capability or perhaps the desire to interact with all the university community because they just couldn't support that. But Unidata represented all of the university communities, and they formed very important strategic partnerships with that one organization that we funded that could represent the voice of the community. And it's been a productive, synergistic way in which technologies developed by Unidata wind up as part of the federal agencies, and new data streams that are coming from the federal agencies actually wind up at the researcher's desk much easier and much quicker. And even sharing cyber infrastructure is something that is important to that. We're hoping in the larger scale that if we can create this, the federal agencies will have a way to talk to the vast intellectual capacity of the universities and capture the best ideas from them, improve their activities, and allow them to carry out a mandate that they have, which is we've spent millions and millions of dollars collecting data. We want to know that it's actually accessible and usable by the research environment. I think we have time for another question or two.
So, Jason Swedlow from the University of Dundee in Scotland. This is fascinating, and especially given the contrast to projects like CA Big, this really sounds terrific. It also looks a lot like what is going on in the S3 mechanisms in Europe, and there's this preparatory phase where the community is encouraged to get together. But as you sort of indicate, at some point, the rubber or maybe the metal hits the road, and there's money involved, and people have to make pretty serious decisions. And I'm just curious how you see that community taking a scientific community, which is used, frankly, to being quite competitive, turning that into a collaborative entity. Do you abstract those scientists away from that? Do you give them a different career model?
Are you asking basically how do we monitor can have the social science be part of the entire process over the longer term?
As we move to funding and actually running those, yeah.
It's a good question. I actually don't know. We have involved this early fellow, and it's not clear to me how we actually involve the social scientists in the long term. I think my expectation is, and of course we have these expectations and we keep changing them with the reality of what the community does, is that sooner or later you might establish a culture. And when I look at some of the things we funded over time is that when the community gets the idea that this is the train that's leaving the station, if you want to be on that train, you can be on it. If you don't want to be on that train, that's fine too, but you might find it increasingly difficult. So there's this sub-element of the social aspect and culture change that people will adapt to over time. That's my hope.
One more question, please.
I'll be very brief here. In your list of 7 failures, you identified two things that spoke very highly to me. On one side, you said you wanted to avoid the build it and they will come mentality. On the other hand, you identified that you wanted to make sure you were able to foresee future needs. How do you draw the line between those two?
I don't think I got the essence of your question. Say that again?
Okay, so there's, in your list of failures, you identified two things that might lead to failure. One of them, of having a method of saying, build it and they will come. We'll just continue to build technology. We'll make it up as we go along. We think this is a good idea, therefore we'll implement it. On the other hand, you identified one of the failures was that you'd build things that wouldn't anticipate researchers' future needs. And I'm curious to know, as an organisation, how do you draw the line between those two things?
Are you worried basically about the incentives for keeping folks involved? Is that the essence of your question? I didn't quite catch it.
How is the process of determining what actually gets done when really at the bottom level? How is that implemented? So who makes the decisions, or how are there guiding principles that say we're going to implement this because of this reason? And how do you draw the line between going those things? I think this is a good idea, therefore I build it, because I think it might anticipate future needs. But if it doesn't...
Yeah. Well, there are a number of people that believe that they, when we got expressions of interest, there were a number of people that basically came to us and said, I have a widget, and it does a lot of things. If you give me a little extra funding, it will do all the things EarthCube wants. Or another folks would come to us and said, I have a widget, and I have 3 people in my university, and we can build something for the entire EarthCube system, even though I have no idea who those people are. So you need to, that particular approach about build it and they will come, we need to redo that mindset. And what we funded all of those people that you saw in an earlier diagram, which we call the concept awards, they all recognized that they were doing very similar things, but they had no way of collaborating. And what we asked them to do at the charrette, and we asked them to do at a workshop, is saying, you cannot have 5 different architectures. You need to come together and say, what will be the architecture for EarthCube? And at least give us the preliminary ideas. And it turns out that is still challenging to them. Nobody is willing to give up what they already had to suddenly adopt another architecture. That's why we want to take, as part of the solicitation, we want to take a separate track on architectures, independent of the folks that were at the table first and already have their architectures for the various activities. So it remains to be seen whether something will come together, but we certainly want to capture the good ideas. So pieces might be, but how do they integrate together in an overall idea, whether it's data brokering or semantics in the Web 3.0 or whatever it is? We're not quite sure of that, but we're asking the community, could you come together and agree on that? They seem to be willing to do that, but they might need a year or two to think this through in terms of giving up what they've already done to move to the next phase of thinking in an integrative way. I hope that answers your question. If not, I'll be available. I think I've used up my time. I do appreciate your attention. Thanks so much. I'll be around the whole conference, so if you want to talk to me, I'll be more than happy to do that.
Thank you very much. Thank you.
I'm great to see you.
Thank you. A small gift, and thank you very much, Cliff, for such a tremendous presentation. As Cliff said, he will be around all week, so there's plenty of time to catch him at the various breaks. And he's also involved in a BOF, that's a Birds of a Feather, at 4:30 to 5:30 in this room on Tuesday, with many other luminaries from Australia, New Zealand, and the UK. And there's a workshop on Friday morning at 9 o'clock on bringing together infrastructure that Cliff's involved in as well. So in fact, there are many opportunities to have a further discussion with him. So thank you very much indeed, Cliff, for your contribution. It's